Welcome back to the Mathquarium, a channel where we break down and simplify math concepts to help you be more successful. If you're new here, please subscribe. And if you'd like to be notified when more videos are available, ring the bell. In today's lesson, we're going to be learning about reference angles. So let's get started. We'll begin with some background information. A 0-degree angle points straight to the right. A 90-degree angle points straight up. A 180-degree angle points straight to the left, and a 270-degree angle points straight down. Once you've made a full rotation of the circle, you're at 360 degrees, which is coterminal with 0 degrees. The angles we just discussed are known as the quadrental angles. They break up the coordinate plane into 4 quadrants. Between 0 and 90 degrees is quadrant 1. That's the upper right side. Between 90 degrees and 180 degrees is quadrant 2. That's the upper left side. Between 180 degrees and 270 degrees is quadrant 3. That's the lower left side. And between 270 degrees and 360 degrees is quadrant 4, and that's the lower right side. Remember, when you're identifying the 4 quadrants, you start in the upper right side and move counterclockwise. 1, 2, 3, 4. Similarly, in radians, between 0 and pi over 2 is quadrant 1, between pi over 2 and pi is quadrant 2, between pi and 3 pi over 2 is quadrant 3, and between 3 pi over 2 and 2 pi is quadrant 4. So what is a reference angle? A reference angle is an angle made between the terminal side of our original angle and the x-axis. So we're looking for the acute angle made between our original angle and a horizontal line. Sometimes we denote our reference angles with a special accent mark called prime. So if our original angle was angle A, our reference angle will be called A prime. And if our original angle was called angle theta, then our reference angle will be called theta prime. Let's see how that works. Let's call our original angle theta. If theta is in quadrant 1 between 0 and pi over 2, then theta is already an acute angle. That means that the acute angle made between the terminal side of theta and the x-axis is the same angle as theta itself. In other words, theta prime, our reference angle, is the same as theta. If theta is in quadrant 2 between pi over 2 and pi, then our reference angle is in the location pictured in red here. Our reference angle, theta prime, can be calculated by subtracting pi minus our original angle, or 180 degrees minus our original angle. And if theta is in quadrant 3, between pi and 3 pi over 2, then theta prime, our reference angle, is in the location pictured in red here. To calculate theta prime, I'm going to take my original angle and subtract pi, or my original angle and subtract 180 degrees. Finally, if theta is in quadrant 4 between 3 pi over 2 and 2 pi, then my reference angle theta prime is in the location pictured in red here. To calculate theta prime, I'm going to take 2 pi and subtract my original angle, or 360 degrees minus my original angle. To summarize this, in quadrant 1, theta prime is equal to theta. In quadrant 2, theta prime is equal to pi minus theta, or 180 degrees minus theta. In quadrant 3, theta prime is equal to theta minus pi, or theta minus 180 degrees. And in quadrant 4, theta prime is equal to 2 pi minus theta, or 360 degrees minus theta. And if you find this table useful as a reference, you can download this table as well as other useful reference documents at my website, mathquarium.org. Now, let's do some examples. For our first example, we'll find the reference angle for 160 degrees. So 160 degrees is in the second quadrant, meaning that to find the reference angle, I need to take 180 degrees and subtract my original angle. That's 180 degrees minus 160 degrees. 180 degrees minus 160 degrees is 20 degrees. That means that theta prime is equal to 20 degrees. Now, let's find the reference angle for 5 pi over 3. 5 pi over 3 is in the fourth quadrant, so to find my reference angle, I need to take 2 pi and subtract away my original angle. That's 2 pi minus 5 pi over 3, which is the same thing as 6 pi over 3 minus 5 pi over 3. 6 pi over 3 minus 5 pi over 3 is pi over 3. That means my reference angle is pi over 3. Now, let's do an example that shows what to do when our angle goes around the circle more than once. Let's find the reference angle for 930 degrees. 930 degrees lands in the third quadrant. This is difficult to tell just from looking at the angle number itself. So the strategy is to find a coterminal angle that lands in the same place. We'd like to find an angle between 0 and 360 degrees that is coterminal with 930. To do that, we're going to subtract away 360 degrees until we get an angle that's between 0 and 360 degrees. Starting with 930 degrees, we subtract 360 degrees and get 570 degrees. But 570 degrees is still too big, so we have to do it again. 570 degrees minus 360 degrees is 210 degrees. That means 210 degrees is coterminal with 930 degrees. Therefore, finding the reference angle for 930 degrees is the same problem as finding the reference angle for 210 degrees. So we'll change our problem to find the reference angle for 210 degrees. 210 degrees is in the third quadrant. That means to find the reference angle for 210 degrees, I need to subtract my original angle minus 180 degrees. 210 degrees minus 180 degrees is 30 degrees. That means that the reference angle is 30 degrees. Since the reference angle for 210 degrees is 30 degrees, that means that the reference angle for 930 degrees is also 30 degrees. And that's our lesson on reference angles. Do you have any unanswered questions? Or do you have ideas for future videos? I'd love to hear from you in the comments below. If you found this video useful, please like and subscribe. And to be notified when more videos become available, make sure to ring the bell. See you next time at the Mathquarium.